All right, to finish up that last problem that we were working on, when we factored 81, we got 9 times 9, and then 9 factored into 3 times 3 times 3 times 3, so we have that group of 4 3s. Here's the only number that isn't in a group, so when we pull one of the 3's out, we get 3/4 root of 3, which is the exact same answer that we got over here. So these are the two methods that I really like to use when I am simplifying radicals. So I'm going to leave that up to you. You can choose whatever method works best for you. All right, so I am going to go ahead and finish up some of these examples here. So now I'm going to go ahead and use the product rule in the opposite way that we initially used it. So up here, when we used the product rule, we were taking two radicals and combining them into one. So now we're going to use it more like this, where we had one radical and we separated it into two. All right, so it does say use the product rule to simplify. So what I'm going to do here is I am going to take out perfect squares. I'm going to rewrite this as 36. And then what is the biggest perfect square that goes into z to the 7th? Well, z to the 6th is a perfect square. And then I have z here. So I'm going to use the product rule and separate this into a perfect square times the square root of z. And I know the square root of 36z to the 6th is 6 times z cubed with the square root of z. All right, so let's do the same thing with a cube root. What is the largest perfect cube in 32? Well, I'm going to break this up into 8. All right, 8 is a perfect cube, and 8 times what is 32? Well, I know 4. What's the largest perfect cube in p to the 4th? Well, p cubed, so I need another p over here. And the largest perfect cube in q to the 7th is q to the 6th. Okay, and you notice each of the exponents I use here, 3 goes in. This index of 3 goes into 3 and 6. So when I use that product rule, I can break this into two radicals. And then I can go ahead and simplify the first radical. So the cube root of 8 is 2, the cube root of p cubed is p, and the cube root of q to the 6th is q squared times the cube root of 4p cubed. All right, and lastly for this group of examples, I'm going to break up 16x to the 15th into perfect powers of 4. Well, I know that 16 is 2 times 2 times 2 times 2, so 16 is a perfect power of 4. But how about x to the 15th? Well, I know a perfect power of 4 is x to the 12th because 4 goes into 12, and I have 3 left over. So I'm going to break this into the 4th root of 16x to the 12th times the 4th root of x cubed. So I get 2x cubed and then multiplied by the 4th root of x cubed. Final answer there. So now let's use the quotient rule in a different way. So in our earlier examples with the quotient rule, you can see that we took our quotients and we split them into two radicals. So what I'm going to do here is I am going to take my quotients, and now I'm going to go ahead and combine them back into one radical. All right. So the only time that I ever actually use the quotient rule to combine these two radicals into one radical is if I know that 5, right, the number in my denominator or the number and variable in my denominator goes into the number and variable into my numerator. So in this case, I'm going to combine these two because 5 definitely goes into 80. And I know that 5 goes into 80 16 times, so I can simplify this fraction. And that makes it really easy to take the square root because I know what the square root of 16 is. It is just 4. All right, so let's take a look at this example. I know that 2 definitely goes into 98, but I have this 3 in my denominator. All right, so if I separate the coefficients of my radicals, I get 1/3 times the square root of 98z over 2. And I want to combine my radicals into 1 because I know that 2 goes into 98. So when I simplify that radical, I get 1/3 times the square root of 49z. And I know that the square root of 49, right, I can separate that out into 49, square root of 49, times the square root of z over 3, which is just 7 square root of z over 3. All right, how about the next one? Should we combine it or should we not? Well, I know that 5 goes into 40, and then I can simplify one of my y's. So yeah, I would definitely combine it. This 5 is in the numerator, so it's going to look like this when I combine it into one radical. 5 times the cube root of 40x to the 5th, y to the 7th over 5y. When I reduce this fraction, I get 5 cube root of 8x to the 5th, y to the 6th. All right, so if I want to reduce this, 8 is a perfect cube, y to the 6th is a perfect cube, x to the 5th is not, but I know that I have one group of 3 in 5x's. So let's reduce that. 8 cube root of 8 is 2. I have one group of 3 in 5x's, so I get x to the 1st outside. I have two groups of 3 in 6y, so I get y squared. So what's left over? Well, the 8 reduced completely, the y to the 6th reduced completely. What's left over when I take the group of 3 x's out? I have a group of 2 x's left on the inside. So this is my, whoa, I forgot to do what? I forgot to multiply the 5 and the 2. So I end up with 10x y squared cube root of x squared. Final answer. All right, and the last major example that we're going to do is this last one right here, where we're going to combine this fraction. So it's going to be 3/5 root of 64x to the 9th y to the 8th over x to the -1 y squared. And I know that when I have a quotient of two quantities that have the same base, I subtract their exponents. So when I subtract their exponents, I get 64. 9 minus a -1 is 10, so it's x to the 10th. 8 minus 2 is 6. So now I need to reduce my numbers. 64, how does that reduce? I know that let's see, 64. Let's reduce that. That is 8 times 8. And 8 is 2 times 2 times 2. So I'm looking for a group of 5. I have one group of 5 2's. So I know that this is going to reduce to 3 times 2. 5 goes into 10 perfectly, so I have two groups of 5 in 10. But I only have one group of 5 in 6y's. So now, what's left under the radical? Well, I have this 2 from my 64 left under the radical. I took two groups of 5 out of 10 perfectly, but I have one y left over. So now when I multiply 3 times 2, I get 6x squared y times the 5th root of 2y. All right, so that's how you do those. So the next section is all about the distance formula and the midpoint formula. These you're going to have to memorize and should already know. You've used them for the last 2 years. So just as a reminder, the distance between 2 points in a coordinate plane is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And this is just another form of Pythagorean's theorem. So let's go ahead and find the distance between these 2 points. And it says give an exact distance and a 3 decimal approximation. I'm not going to give the 3 decimal approximation. You guys know how to use your calculators. So I'm just going to go ahead and plug these in. I'm going to call this x1 or x2, y2, this x1, y1. All right, so according to the rules, I take -2 and I subtract a -3 from it and then square it and then add 3 minus 7 squared. So this turns into an addition, so -2 plus 3 is 1 squared, and this is going to be -4 squared. So I get, under my radical, 1 plus 16. Remember, we can't separate this out because we only separate what's under the radical using the product rule. If we have a product and we don't have a product, this is a sum, so we must add the two. And my final answer is the square root of 17. And then lastly, I'm going to use the midpoint formula here. In this example, and remember our midpoint is just the average of the x's, right? This is an average of the x components of our point and the y components of our point. So we're just taking the average of these two numbers. So the midpoint for this, let's say this is x1, y1, x2, y2. I'm just going to average my x's, so to average I add them and divide by 2. And then I'm going to average my y's, -2 plus a -6 over 2. Well, that's going to give us 13 over 2. And that's going to give me a -8 over 2, which just when I reduce this is 13 over 2, comma, -4, final answer. Okay, so now you should go on to Canvas and answer the brief question that I have for you about the videos that you watched, and then you guys can do your homework anytime during the day for this section.